Today we are continuing to review what you learned in Algebra 1 about solving systems of equations. So we already reviewed how to solve them by graphing, which poor graphing often gets ignored because it's not everyone's favorite method because you have to draw a graph and get it into slope-intercept form and a whole bunch of steps. Now, I have a whole bunch of steps written out here. Many of you completely remember how to solve a system using substitution or how to solve a system using linear combinations. I have all the steps written out here. You can read through them. If you're a person who is struggling, you should read through them each time you practice a problem. I'm not going to read through them now. I'm going to refer to each step as we solve the individual problems. So, our learning goals for today, we need to be able to solve a linear system using substitution, which is our first algebraic method. We also need to be able to solve a linear system using linear combinations. Eventually, we're also going to need to be able to model a given system using, or given situation using a linear system, which basically means that we will get to some word problems, not in these notes, but just keep in mind that you will have to be writing these systems based on real-world situations eventually. So what we have here, first example 1, to go with the first learning goal, solve the system by substitution. So my first step says get a variable by itself in one of the equations. So it doesn't matter which equation and it doesn't matter which variable, but I know I certainly am, and hopefully many of you feel the same way, that I want to do as little work as possible for each step. So if I want to choose a variable to get by itself, here's what you're looking for. The easiest variables to get alone are variables with a coefficient of 1, meaning the number in front of it is 1. And if you don't have one with a 1, you might try one with a negative 1. If you don't have either of those, then it's probably just doesn't really matter which one you pick. They're all going to be the same amount of work. So I look here, and you have 4 choices because there are 4 variables, 2 sets of an x variable and 2 sets of a y. None of them have a coefficient of 1, but this x right here has a coefficient of negative 1. So that is what I am going to choose for my first step to get by itself. So if I want to get that x by itself, and I'm going to label my steps. You do not have to label your steps. However, please either work completely vertically or completely horizontally, because if I can't read your work and figure out what you did, I can't give you partial credit. So you don't have to label the steps, but please do work either straight down or straight to the right so that I can read as I go. So first thing I'm going to do if I want to get that x by itself in that equation is I am going, after I copy the equation that I'm choosing, I'm going to subtract that 3y. So subtract 3y from both sides. These are going to cancel. I've got negative x remaining on the left. On the right, these are not like terms, so I've got negative 3y plus 1 or 1 minus 3y. It doesn't matter which way you write it. So now, I've got negative x, but I want to know what x equals. I need to get the variable alone, so I need to divide everything by negative 1. So that's going to give me x equals 3y minus 1. So this is the end of my first step. The next step says take that variable, meaning the one that you just got by itself, take that variable out of the other equation. So that means I go to the other equation. I'm going to take my x out. So in step 2, I'm going to take my x out of that equation. Now, many of you don't need this step, but if you struggle, this is what you should do. Literally take it out and leave a hole there. Everything else about the equation stays the same. The only thing you're doing with this second equation is taking out the variable you just got alone. So I took out my x. Then it says, and replace it with what that variable was equal to. So my x was equal to 3y minus 1. So I'm going to replace where the x was with 3y minus 1. So that's step 2. Step 3 is to solve that revised equation for the variable that's left. That equation only has y's in it. So if I distribute my 4, it gives me 12y minus 4 plus 6y equals 8. So combine these like terms here. That gives me 18y minus 4 equals 8. Add the 4 to both sides. (18y equals 12). And then finally divide by 18. So 12 over 18 does not come out evenly, but it does reduce. They're both divisible by 6, so make that 2 over 3. Yes, your answers need to be in simplest fraction form unless there was a decimal in the original problem. So I'm done with step 3. I know what y is. So that's good. Step 4 says plug that value into the equation from step 1. So at the end of step 1, I had this equation where x was by itself. So now I'm going to use that in step 4, and I'm going to plug that in for y. So I've got x equals, instead of the y, I'm putting in what I know it's equal to, which is 2/3, and then minus 1. 3 times 2/3 is just 2, so x equals 2 minus 1, which is 1. So I plugged it into the equation, I solved for the other variable, so now I know x and I know y. Your final step, do not forget this one. It is necessary. You can't just say x equals this, y equals this, because remember, solution of a system is representing an intersection point. So you have to list your answer as an ordered pair. Remember, x always comes first. It's alphabetical order, so 1, 2/3 is my ordered pair. Also remember that anytime you solve a system, you should be able to check your answer by plugging it back in. You should get a true statement in both of them. If you don't, then you might have done something wrong. All right, so that's the substitution method. Let's try that one more time. So follow the steps. See if I can get a little more room here. So I'm going to start up here. Step 1, I need to look at these variables and determine which one's going to be easiest to get alone. So I'm looking for a coefficient of 1 or -1. That's 9, -3, -3. Here's a coefficient of 1. So I'm going to start with that second equation this time. And that didn't come out right. My wrist hit the thing. That's an equal sign. So if I want to get y alone, I need to add 3x to both sides. So y equals 3x minus 5. So y is alone. I'm done with step 1. Step 2, take that variable out of the other equation. So right here, I solved for y in the first step, so I'm going to take y out of the second in the second step. So 9x minus 3, I leave a blank there, equals 15. And then I plug what y was equal to in its place. So that's step 2. Step 3 is to solve that. So I have some distribution to do here. So 9x minus 9x plus 15 equals 15. Combine these like terms. 9x minus 9x is 0x, so just 0. And I end up with just 15 equals 15. Now, there's no variable there. So when I go to do my next step, solve the equation for the variable that remains here in step 3, I can't solve for the variable because they're all gone. Now, that doesn't necessarily mean that I messed up. This is one of our special cases. So just like with the graphing we had special cases, you have the same type here. This is just an algebraic way of solving it instead of graphing. When your variables drop out, it is either a no solution or an infinitely many solution. The way you know the difference is whether what is left, in this case 15 equals 15, is a true statement or a false statement. This one is a true statement. 15 does equal 15. True statement remains means that this has infinitely many solutions. Now, we should really like these special cases when we're solving algebraically because it means that there's less work for us to do. I only got to the end of step 3. 4 and 5, I didn't have to do it all because I knew that there was no solution, or infinitely many solutions, sorry. All right, so that is a review of the substitution method from Algebra 1. Now we are going to review the linear combination method. Again, I wrote out the steps up here if you need them. Our first step is to multiply one or both of the equations by a constant, meaning a plain number, that will give you opposite coefficients on either your x's or your y's. This is your main objective in the linear combination method. You need either your x's or y's to have opposite coefficients. Opposite coefficients mean it's the same number but a different sign. So you're looking for 3x and negative 3x, x and negative x, 2y and negative 2y. Not just one positive and one negative, literally opposite numbers of each other is what you're looking for. So when we look at example 2, part A, I have 2 and negative 5. Those aren't opposites. 3 and 5 are also not opposites. Now, sometimes when you look at these, they're already opposites for you. And if that's the case, step 1 is already done. Here it's not. So I am going to ask myself, is there anything I can multiply 2 by to get the opposite of negative 5? Well, the opposite of negative 5 is 5, and there's nothing, no constant that I can multiply 2 by to get that. That's not a fraction. So I'm going to look at the y's, but the same thing is true. The only thing I could multiply 3 by to get a negative 5 is going to be a fraction. So when that happens, that means we're multiplying both equations. And this is kind of like an LCD type idea that you're trying to get. You want to get a multiple of negative 5 that is also going to be a multiple of 2. So start with the bigger one. In this case, negative 5. If I double 5, I get 10. You ask yourself, does 2 go into 10 evenly? Yes, it does, so that means that's exactly what I'm going to do. I'm going to double 5, in this case, negative 5. So I'm going to multiply the bottom, I'm going to multiply the bottom by 2. So that's going to give me negative 10 on my x's. If I have negative 10 on my x's, that means I want positive 10 for the top equation, x's. So to get positive 10 when I have 2, I need to multiply by 5. So this is step 1. That's what I need to multiply by. And what I get when I do that is what I'm going to write over here for my step 1. 5 times 2x is 10x. I'm just distributing here. 5 times 3y is 15y. 5 times negative 1 is negative 5. On the bottom, 2 times negative 5x is negative 10x. 2 times 5y is 10y. 2 times 15 is 30. My pen's messing up. There we go. So now I have achieved the goal of step 1. I have opposite coefficients, in this case, on my x values. So my step 1 is done. Step 2 is to add the two equations together. So in step 2, I'm going to add, and I'm going to add straight down in the columns because that's where my like terms are. So 10 plus negative 10 is 0, so these cancel out. On the y's, 15y plus 10y is 25y. On my plain numbers, negative 5 plus 30 is 25. It says, and solve what remains. So I added. Now, to solve for y, I just divide by 25. So y is 1. So I'm done with step 2. Step 3, plug that value into one of the original equations to solve for the other variable. Does not matter in this case which equation you plug it into. I usually choose whichever one has smaller numbers, so I'm going to go with the top one. So 2x plus 3 times 1 equals negative 1. So 2x plus 3 equals negative 1. Subtract 3. 2x equals negative 4. And then divide by 2 to get x equals negative 2. So x equals negative 2, y equals 1. Last step, don't forget it, is to list it as an ordered pair. So x is negative 2, y is 1. There is my final answer. Again, remember that you can plug it in to check it. That way you know your answer is correct. All right, let's practice that one again because the multiplying can sometimes be a little confusing. So I look here, 6 and negative 3, those aren't opposites. Negative 4 and 2, also not opposites. So I look, and it doesn't matter which one we're looking at. Let's say I'm looking at the y's this time. And I ask myself, is there anything I can multiply 2 by to get the opposite of negative 4? Well, the opposite of negative 4 is positive 4, and I can multiply 2 by 2. So that means on this one, I only have to multiply the bottom equation. The top equation can stay, and I'll still have my opposites. So in step 1 this time, I just recopy the top equation because I didn't have to multiply it by anything. The bottom equation, now multiply it by 2, so that gives me negative 6x plus 4y equals 14. So again, I've got those opposites on my y values. That's what I was after. Step 2, add them together. When I do that, my x's cancel also. 6x plus negative 6x is 0. Negative 4y plus 4y is 0, which means there's absolutely nothing on the left side. It's 0. On the right side, 14 plus 14 is 28. Again, when I go to finish step 2, to solve what remains, I can't because all my variables are gone, which means, go back up here, it's one of your special cases. 0 equals 28 is a false statement because 0 does not equal 28. So when you get a false statement, that means that this is a system where there is no solution. All right, last one. So looking at C, I want to get my opposites. There's nothing I can multiply 6 by to get 9. There's nothing I can multiply 4 by to get 5, so I'm going to have to multiply on both equations here. So I'm going to go ahead and deal with the y's because the numbers are smaller. So 5's bigger. If I multiply 5 by 2, that gives me 10. 4 doesn't go into 10 evenly. By 3 is 15. 4 doesn't go into 15 evenly. 5 times 4 is 20, and 4 does go into 20. So if I multiply the top by 4, whole thing, this is going to be squished to get it in, 36x minus 20y equals negative 28. So now I need to decide what I need to multiply the bottom by. Because again, I was looking at the y's. If this is negative 20, That means I need to multiply something that's going to give me positive 20 here. So 4 times 5 gives me positive 20. So multiply that 5 times everything. 5 times negative 6x is negative 30x. 5 times 4y is 20y. 5 times 2 is 10. So now I have my opposites right here, negative 20 and positive 20. So that's the end of step 1. Step 2 now is to add them straight down. So 36x plus negative 30x is 6x. My y's are opposites, so they drop out. My plane numbers, negative 28 plus 10 is negative 18. So to get x alone, which is the second part of step 2, I need to divide by 6, and x is negative 3. So now, that's the end of step 2. I know what x is. Step 3, plug that value into one of the original equations. Again, it doesn't matter which one you plug it into. They both have decently large numbers in comparison to the other one, but equation 2 is a little smaller, so I'm going to try that one. So negative 6 times x, which is negative 3, plus 4y equals 2. Negative 6 times negative 3 is 18. So simplify there. Now get y by itself, so subtract 18 first. So 4y on the left, because these canceled. 2 minus 18 is negative 16. And then divide by 4. So I get y equals negative 4. Do not forget the last step. List your answer as an ordered pair. So x comes first, negative 3. Y comes second, negative 4. Once you have it listed, don't forget to plug it back in to check to make sure it's correct. Always check to make sure it's correct. Then you should have no excuse to not have them all right. And that is it for this lesson.